November 1942, a workshop outside Berlin. 3 engineers stood around a table. On it, pieces of wood and fabric, the remains of something that shouldn't have existed. They'd been ordered to understand it, to find the weakness, to explain how a wooden plane was outrunning every fighter Germany had. They couldn't. The Mosquito wasn't supposed to work. Wood rots, wood burns, wood splits at high altitude when the temperature drops to 40 below zero. Every aviation expert knew this. The Germans knew it. The British knew it too. That's why they stopped building wooden aircraft in 1918. But someone didn't listen. And now German radar stations were tracking something that appeared for 30 seconds and vanished. Something that flew higher and faster than a Messerschmitt. Something made of plywood and glue. When the first intact Mosquito fell into German hands, the order came from the top. Take it apart. Find out what makes it work. Find out how to stop it. What they found wasn't the weakness. In 1940, Britain was losing. Not just battles, the entire war. The Luftwaffe had destroyed factory after factory. Aluminum was running out, so was steel. So were the workers who knew how to shape metal into aircraft. One man saw this and made a decision that sounded insane. Geoffrey de Havilland, 58 years old, an aircraft designer who'd been building planes since before the First War. He walked into the Air Ministry with a proposal: build a bomber out of wood. Not a trainer, not a reconnaissance plane, a frontline bomber that could reach Berlin and come back. The officials listened. Then they said no. Wood was obsolete. Everyone agreed on this. The Americans were building all-metal bombers. The Germans had metal fighters. Even training aircraft were being made from aluminum now. De Havilland didn't argue. He went back to his workshop and built it anyway. The design was simple in concept, impossible in execution. 2 Rolls-Royce Merlin engines, the same engines used in Spitfires. No defensive guns, no gun turrets, no gunners, just speed. If you're faster than the enemy, you don't need armor, you don't need weapons, you just need to stay ahead. The Air Ministry called it a death trap. They were wrong. The first prototype flew in November 1940. Test pilot Geoffrey de Havilland Jr., the designer's son. The report came back in 4 words. It's faster than anything. 390 miles per hour in level flight. The fastest German fighter at the time could barely touch 350, and that was at maximum throttle, burning fuel they couldn't afford to waste. The Mosquito could cruise at that speed. But speed wasn't the problem the Germans worried about. They had faster designs on paper, jet engines in development, rockets. The problem was the wood. Every intelligence report said the same thing. The British were running out of materials. Their metal bombers were being shot down faster than they could build replacements. They were desperate. So why would they waste resources on a wooden aircraft unless they had no choice? The assumption was clear. The Mosquito was a stopgap, a temporary measure until real bombers could be produced. It would fall apart in combat conditions: high altitude, extreme cold, moisture, stress. Wood couldn't handle that. The first Mosquito raids proved otherwise. September 1942, a Mosquito dropped 4 500-pound bombs on a railway junction in Denmark. It flew in at treetop level, hit the target, and disappeared before the air raid sirens finished sounding. No German fighter got close. October, 4 Mosquitoes attacked the Gestapo headquarters in Oslo. Daylight raid. They flew so low that witnesses said they could see the pilots' faces. Every bomb hit, 0 losses. The Luftwaffe sent up fighters. By the time they reached altitude, the Mosquitoes were already crossing the North Sea. November, the captured Mosquito arrived in Germany. It had been shot down over Holland, crash-landed in a field. The crew didn't survive, but the aircraft was mostly intact. The order came from Reich Marshal Hermann Göring himself. Find out what makes it work. The team assigned to the task wasn't inexperienced. These were men who designed the Messerschmitt 109, the Focke-Wulf 190. They understood aerodynamics. They understood structural engineering. They didn't understand what they were looking at. The fuselage was 2 shells of plywood, thin sheets, curved and joined together. Between them, a core of balsa. Balsa, the lightest wood available. So light it was used for model aircraft, for toys. No metal frame, no internal structure of steel or aluminum. Just wood bonded to wood. The wings were the same. Plywood skins, spruce spurs, everything held together with adhesive. One engineer put his hand on the fuselage and pushed. It flexed, just slightly, like it was breathing. He pushed harder. It didn't crack, didn't split, just returned to its original shape. That shouldn't have been possible. They started with the joints, where the wings met the fuselage, where the tail attached, the point where stress would be highest. Standard aviation practice used bolts, rivets, mechanical fasteners that could be inspected, replaced, tightened. The Mosquito used glue. Not ordinary wood glue, something else. Something that had bonded the wood so completely that it was impossible to tell where one piece ended and another began. They tried to separate a joint, carefully at first, then with force. The wood split, the glue didn't. They tried another joint, same result. The wood fibers tore apart before the adhesive gave way. One of the engineers wrote in his report, "The bonding agent appears to be stronger than the material it joins." That sentence was underlined 3 times. The Germans had wood adhesives. They'd used them in the last war for aircraft like the Albatross and the Fokker. But those glues had failed. They weakened in moisture. They degraded in heat. They turned brittle and cold. That's why everyone stopped using them. The British glue didn't fail. They tested it, froze samples to -40 degrees Celsius, the temperature at 25,000 feet. The glue held. They heated samples to 50 degrees, the temperature inside a closed hangar in summer. The glue held. They soaked samples in water for weeks. The glue held. They couldn't break it. The chemists analyzed it. The formula wasn't complex. Synthetic resin, urea formaldehyde. Nothing exotic, nothing Germany couldn't produce. But the application was different. The British had figured out how to cure it under pressure, how to get it to bond at the molecular level, how to make it flex with the wood instead of fighting against it. The report went up the chain. Eventually, it reached Göring. His response was brief. If wood is this strong, why aren't we using it? The answer was complicated. Germany could build wooden aircraft. They had the trees, they had the engineers, they had the workers, but they didn't have time. The Mosquito took longer to build than a metal bomber. Each fuselage required precision. Each joint needed to cure for days. You couldn't rush it. And Germany needed aircraft now. The Battle of Stalingrad was consuming fighters faster than factories could replace them. The bombing campaign against Britain required heavy bombers, 4-engine metal monsters that could carry tons of explosives. A wooden aircraft didn't fit the doctrine. So they studied it, documented it, and filed it away. But the Mosquito kept flying. By 1943, Mosquitoes were everywhere. They flew reconnaissance missions over Germany at 40,000 feet, higher than any fighter could intercept. They led bomber streams into Germany, dropping flares and marking targets. They attacked railways, bridges, factories, Gestapo headquarters. The Luftwaffe tried everything. They positioned fighters along known flight paths. The Mosquitoes changed routes. They used radar to predict where Mosquitoes would cross the coast. The Mosquitoes flew too low for radar to track. They developed faster fighters. The Mosquito was modified to go faster. In 4 years of war, the loss rate for Mosquito operations was the lowest of any Allied bomber. Not because it was lucky, because it was built correctly. The glue was called Aerolite, a 2-part adhesive developed by a company called Aero Research Limited. The formula was simple, the process wasn't. Each joint had to be prepared exactly right. The wood had to be clean, dry, cut to precise angles. The glue was applied in thin layers. Too much and it wouldn't cure properly. Too little and the bond would be weak. Then pressure. Clamps holding the pieces together while the resin hardened. Days of waiting while chemical bonds formed. Workers couldn't see if they'd done it correctly until the clamps came off. If the joint failed then, the entire section had to be scrapped. The failure rate in early production was 20%. By 1942, it was less than 2%. The workers had learned, not from manuals, from repetition, from muscle memory, from understanding how wood moved and how glue behaved. You couldn't teach that in a classroom. That's what the German engineers realized. Even if they copied the formula, even if they built the jigs and presses, even if they replicated every measurement, they couldn't replicate the knowledge. There's a memo from late 1943, written by a Luftwaffe engineer named Kurt Tank, designer of the Focke-Wulf 190. He'd reviewed the Mosquito analysis, he'd studied the construction methods, and he'd come to a conclusion. The British haven't built a wooden aircraft. They've built a wooden aircraft correctly. These are not the same thing. He proposed Germany do the same. Use wood where metal was scarce, train workers in adhesive techniques, accept longer production times in exchange for resource efficiency. The proposal was rejected. By 1943, Germany was committed to metal, to mass production, to turning out hundreds of fighters as fast as possible. Quality didn't matter if you couldn't build enough. But the British made a different calculation. They knew they couldn't outproduce Germany. Germany had more factories, more workers, more raw materials from occupied territories. So they built fewer aircraft, better aircraft, aircraft that came back. The Mosquito was the perfect expression of that philosophy. It used materials Britain had in abundance, wood from Canadian forests, glue from British chemical plants, and it used workers who weren't trained in metalwork, furniture makers, carpenters, piano builders. And it used an assembly process that distributed production across dozens of small workshops. If one was bombed, the others kept working. You couldn't bomb the Mosquito program out of existence. The Germans tried. In 1943, the Luftwaffe targeted the de Havilland factory in Hatfield. 22 people died. Production stopped for 3 days. Then, it resumed. Because the factory in Hatfield was just one facility. There were workshops in Leavesden, in Chester, in Canada, and Australia. You'd have to destroy them all. The Mosquito's success wasn't just engineering. It was philosophy. Most nations designed aircraft around what they wanted to achieve. Britain designed the Mosquito around what they had available. They had wood, they had glue, and they had skilled craftsmen who understood both. So they built an aircraft that played to those strengths. The result was something that shouldn't have worked. A wooden bomber in an age of metal, an unarmed aircraft in a war defined by firepower, a precision instrument built by hand in an era of mass production. It worked because someone understood that limitations can be advantages. If you don't have aluminum, you don't need to compete with countries that do. You find something else. The German engineers who examined that captured Mosquito in 1942 wrote dozens of reports. Technical analyses, stress calculations, chemical formulas. But there's one sentence that appears in multiple documents. We cannot replicate this with our current methods. Not, we don't have the materials. Not, we don't have the technology. We cannot replicate this. Because replication isn't just copying, it's understanding. The Mosquito wasn't a design, it was a system that included the workers who built it, the materials available, the strategic situation, the industrial capacity. Remove any one element and it doesn't work. Germany tried to build wooden aircraft later in the war, when metal became critically short, when aluminum was reserved for jets and rockets. They built the Heinkel HE-162, a wooden jet fighter. It was fast, maneuverable, dangerous to fly. The glue failed at high altitude. The wood warped in humid conditions. Joints separated in flight. Pilots called it the salamander because it had a tendency to catch fire. The difference wasn't the materials, it was the knowledge. The British had spent 3 years learning how to work with wood adhesives, how to cure them, how to test them, how to trust them. The Germans had 3 months. By 1944, the Mosquito had evolved. Fighter variants with 4 20mm cannons, night fighters with radar, photo reconnaissance aircraft that could photograph Berlin in daylight, and bombers. Modified bombers carrying a single 4,000-pound bomb, the Cookie, a weapon so large it had to be loaded through special doors, a weapon designed to destroy entire buildings. Mosquitoes carried these bombs to Berlin, Cologne, Hamburg. They flew in darkness, too fast for night fighters, too high for anti-aircraft guns. The German reports called them terror mosquitoes, not because they caused terror, because they were impossible to stop. There's a photograph from 1944, a Mosquito being assembled in a workshop in High Wycombe. The workers are women, older men, people who wouldn't normally build combat aircraft. They're applying glue to a fuselage joint, careful, precise, taking their time, because rushing meant failure, and failure meant a crew wouldn't come home. That's what the German engineers didn't see when they examined the captured aircraft. They saw wood and glue. They saw joints and stresses. They didn't see the culture that built it. A culture that valued precision over speed, that trusted craftsmen over machines, that understood some things can't be rushed. The war ended in 1945. The Mosquito kept flying. Britain used them until 1955, 10 years after the war ended. Long after jet fighters had replaced propeller aircraft, long after metal had become abundant again, because they still worked. The wooden aircraft outlasted the metal aircraft it competed against, the Messerschmitts, the Focke-Wulfs, the Junkers. Those aircraft are in museums now, historical curiosities. The Mosquito stayed in service. There's an irony in this. The Germans thought the Mosquito was a sign of British weakness, a desperate measure born of material shortages. They were half right. It was born of material shortages, but it wasn't weakness. It was adaptation. The ability to look at what you don't have and build something from what you do have. That's not desperation. That's intelligence. In the end, the Mosquito wasn't about wood. It wasn't about glue. It was about understanding that the best solution isn't always the obvious one. Everyone knew metal was better than wood, stronger, more durable, more modern. Everyone was wrong. In the specific context of 1940s Britain, wood was better. Not because of its properties, because of what it allowed. It allowed Britain to build aircraft without aluminum, to employ workers without metalworking skills, to distribute production across small workshops that were hard to target. It allowed it to build an aircraft that was fast enough to survive, cheap enough to produce in quantity, reliable enough to trust. And it allowed one man with an idea to prove that conventional wisdom isn't always wisdom. The captured Mosquito that German engineers examined in 1942 is gone now, probably scrapped after the war, melted down from materials, or destroyed in a bombing raid. But the reports survive. Pages and pages of analysis, diagrams, chemical formulas, stress calculations, and buried in those reports, that one sentence: the bonding agent appears to be stronger than the material it joins. It wasn't just an observation about glue. It was a metaphor for the entire aircraft. The Mosquito was stronger than the materials it was made from, not because of chemistry, because of thought, Because someone looked at plywood and saw possibility instead of limitation. Jeffrey de Havilland died in 1965, 20 years after the war ended. By then, the Mosquito was already history, replaced by jets, by missiles, by aircraft made of aluminum and titanium and composites. But the lesson remained. The best weapon isn't always the most advanced. Sometimes it's the one that uses what you have instead of what you wish you had. The Germans never learned this. They built Tigers when they needed T-34s. They built V-2 rockets when they needed trucks. They built jet fighters when they needed fuel. They optimized for perfection in a war that rewarded adequacy. The Mosquito was adequate. It was just adequate at everything. Fast enough, strong enough, cheap enough, reliable enough. And enough turned out to be exactly what was needed. There's a memorial in Salisbury Hall, the place where the first Mosquito was designed. It's a small building, quiet, not many visitors. Inside, there's a plaque. It lists the production numbers. 7,781 Mosquitoes built between 1940 and 1950. Below that, the loss rate. 2% of all Mosquitoes built were lost to enemy action. For comparison, the Lancaster bomber lost 10%. The B-17 lost 12%. Those were metal aircraft, armored, defended by gunners. The Mosquito was wood and glue. It survived better. The engineers who examined that first captured Mosquito were right about one thing. The glue was stronger than the wood. But they missed the larger truth. The idea was stronger than both. The idea that you don't need the best materials to build the best aircraft. You just need the right materials used correctly. In the workshops where Mosquitoes were built, there were rules. The wood had to be stored at specific humidity levels. The glue had to be mixed fresh each day. The temperature in the assembly area had to stay between 60 and 70 degrees. These weren't suggestions. If the humidity was wrong, the wood would warp. If the glue was old, the bond would be weak. If the temperature was off, the curing process would fail. There was no room for approximation. This wasn't mass production. This was precision manufacturing using traditional materials. The Germans could have done it. They had the trees, they had the chemists, they had engineers who understood stress and aerodynamics. What they didn't have was patience. Building a Mosquito took time, weeks of work for a single aircraft. Germany needed hundreds of fighters immediately, so they built quickly, sacrificed quality for quantity, accepted higher loss rates because they could replace aircraft faster than Britain could. It was a logical decision. It was also wrong. By 1945, Germany had lost the war, not because they had inferior technology. They had jets before anyone else, they had rockets, they had advanced radar. They lost because they ran out of fuel, out of pilots, out of time. The Mosquito was still flying, still fast enough, still reliable enough, still made of wood and glue. After the war, aviation moved on. Wood became obsolete for real this time. Jets required metal, supersonic flight required new alloys. Nobody builds wood in combat aircraft anymore. But the principle remains. Constraints force creativity. The Mosquito existed because Britain couldn't build metal bombers fast enough. If they'd had unlimited aluminum, they never would have tried, and they would have missed something extraordinary. There's a Mosquito in the RAF Museum in Hendon, suspended from the ceiling, painted in the camouflage scheme used for night operations. You can walk underneath it, look up at the fuselage. It's still wood, 80 years old, still holding together. The glue hasn't failed. That's what the German engineers found when they tore apart that captured aircraft. Not a weakness, a strength they didn't understand. Not because they lacked knowledge, because they asked the wrong question. They asked, why is Britain using wood? The right question was, how did Britain make wood work? The first question assumes failure. The second seeks understanding. Germany asked the first question. Britain answered the second. The Mosquito flew its last combat mission in 1955. a reconnaissance flight over Malaya, 15 years after the first prototype flew. In those 15 years, aircraft design had changed completely. Jets had replaced propellers, missiles had replaced guns, radar had replaced visual sighting. But the Mosquito kept working because it was built correctly. Not built with the most advanced materials, not built with the latest technology, built with an understanding of what materials could do if you respected them. Wood can be strong if you bond it correctly. It can be light if you use the right species. It can be durable if you protect it from moisture. It can be all of these things, but only if you understand it. The reports written by those German engineers are stored in archives now, declassified, available to researchers. They make interesting reading. Page after page of analysis, measurements, calculations, and that one repeated observation: we cannot replicate this. Not we won't, we cannot. Because replication requires more than copying. It requires understanding why something works. And sometimes the why is more complicated than the what. If you know someone who served, who worked on aircraft, who remembers when wood and fiber still flew in combat, ask them about it. Their stories matter. Also, let us know in the comments where you're watching from. United States, United Kingdom, Canada, Australia, Germany, or anywhere else in the world. And if you found this story worth your time, consider subscribing. There are more stories like this. Stories about the moments when someone made the right choice for the wrong reasons, or the wrong choice that somehow worked. History isn't always logical, but it's always worth understanding.